Now then, crew, welcome back to the Andy Mechanic YouTube channel. It's been quite some time since I've had a sort of a free day to do my own sort of stuff in the workshop. I've been doing jobs for lots of other people, and I've been collecting a load of winches. That's right, we've done some videos on winch repairs, strip downs, diagnostics, all that kind of stuff, how the contactor block works. But I've got 3 more winches, and they're actually all the same model, which is really cool. My aim is to make a good one out of 2 of the used winches, and I've also got a brand new one of the same WARN winch model. So I was setting up a little test rig just to make sure it was all working correctly, because you never quite know when they come out of the box. Plus the contactor block that I've got, that's what WARN called it, it's like the relay block. The solenoid block, if you're an Englishman. I wasn't sure if that was working correctly or not, and I will need one to install the new winch onto one of my trailers. If I can get a good winch out of the other 2, then I'll install that winch on my other trailer, and that way I don't have to try and push ROVs back onto the trailer when they won't start, which does happen now and again. I do the odd breakdown. So without further ado, let's take a quick look at the rig, the setup, and then we'll talk about how the contactor block, the solenoid pack, is actually wired up. And this is, I get a lot of questions about this. It is in a previous video, but I think the diagrams that I've made on this video are a little bit clearer to understand. So we're going to cover all of the terminals on the solenoid and what you connect each one to in order to wire the winch up correctly on your bike or your side-by-side. If you want to know what's inside the contactor block, then on a previous video we actually pulled one apart and you can see how they corrode inside, because these WARN contactor blocks, they're not fully waterproof and they do fail. And it's quite an interesting video, actually, quite enlightening as to what really goes on the inside and how they degrade. Certainly helps with diagnostics as well. So without further ado, let's head across to the little bench and I'll show you what I've set up. Here we go. Used.
You don't paint something without warping.
Honestly. Right, it's sort of one of those quick and dirty videos. I'm not going to try and take too long doing this one, but I know a lot of people have winches nowadays on their ATVs and the 4-wheel drives and the ROVs, side-by-sides, call them what you like. And I thought this video might be quite helpful to people trying to wire up a winch, or maybe do some repairs and diagnostics as to why a winch doesn't work. Anyway, the winch in question here we've got, this is a brand new winch. It did get damaged in transit, it had a little bit of a bent lug on here, but I've managed to straighten that out and it's just fine. It's a WARN VRx45, so it's 4,500 pound pull rate. There you go, look, you can see it on the side there, look. What's that in kilograms? 2 tons. So an Englishman, just over 2,000 kilograms capacity, and it's 6.4 mil aircraft grade wire. It's all very shiny and nice. Now I have clamped it down to the bench so it doesn't wander around, and we're using all the standard WARN color code cabling, something we didn't do in the past, so again it should help. If you look on the motor, we've got the negative symbol here and the positive symbol here, and WARN have even put us a little color coded washer, plastic sort of insulator on each side, so the yellow wire they supply should go to the positive on the motor, hence the little yellow white washer, and the negative should be the blue wire, and again you've got a little blue washer in there, coloured washer, plastic obviously, which is really helpful. I do like the WARN winches, always been a huge fan of them. The contactor block is also labelled up colour coded, so you can't really get it wrong, to be honest. You've got the yellow wire coming in, connects to the terminal with the yellow dot nearest to it, and then of course the blue wire comes in and connects to the terminal with the blue dot. Now the battery side we're using a really small battery. This is an ATV battery. If it's a four-wheel drive, it's a much bigger battery, but the principle is exactly the same. If we come around this side of the relay, you'll see that we've got the battery negative, the heavy black cable on the terminal next to the black dot, and of course the red cable on the terminal against the red dot. Very, very simple. Just follow the color codes. You can't go wrong. And we go across the battery, and of course the heavy red cable goes to battery positive, and the black cable goes to battery negative. Again, very, very simple. One thing to just note at this point in time, and we'll come to this a bit later on in the video, and there might even be a separate video on it, who knows. There's no fuse. There isn't. And this is the big problem with winch installations in general, is these cables are bolted to the battery. You know, it takes a few minutes to take them off if need be. And of course they're bolted to the contactor block, and they're bolted to the winch. So imagine the scenario, and I've known this happen many times, where the contactor block, this solenoid here, jams in the spool-in condition. Or spool out, to be fair, but spool-in's even worse. So the winch wire's currently being eaten up by the drum, it's heading towards the fair lead, and there's nothing you can do. You know, you can't just release the button on the controller because it's the solenoid block that's jammed, you know, and it's spooling in, and eventually this wire is going to hit the fair lead, and then the motor's going to start to jam and stall, and it's going to create a huge amount of current draw, and that potentially is going to start to melt stuff. It's certainly going to very, very quickly discharge your battery, and in some cases it'll cause a fire. It's really, really bad. So what's a very good idea is to fit on the battery positive a battery isolation switch. And for this kind of winch, a 100 amp one that you find in rally cars and stuff, Hella make them, many other brands do as well, where you would actually cut this wire somewhere along its length and mount a switch. I'll put a little picture in the video for you as an example, and basically if anything goes wrong, you can just cut the power and there's no more power to the motor, and everything just stops, and it's safe. You can also get a thermal coupling that WARN used to produce, and they probably still do, that you can actually you can mount in line, and if the current draw gets too high, it through a bimetal strip, it automatically cuts power to the winch, and hopefully no damage is done. Personally, I prefer the switch type as opposed to the automatic type, because it gives you a lot more control, and it also stops people using the winch that shouldn't be using the winch. So you can just take the key out and it's hidden away and the winch won't work. That's the best option. Anyway, we do digress. That is the setup. Now you might wonder, Andy, you've also got some more wires here. Look, well, we have, and this is quite an important part. These mimic the controller, you know, the handheld controller, and on the contactor block you've got 3 small terminals, and this is the trigger circuit. The middle terminal is battery negative. A lot of people seem to think it's battery positive. It's not. That should be battery negative. And then there's a positive feed fed to either one of these terminals, depending on whether you want to spool in or spool out. And we've got that on the diagram, so I'll talk you through that shortly. But what I can do is this little wire here is connected to battery positive, and I can very gingerly, I can connect it to that terminal. And if you watch the winch, that's spool in, and if I connect it to that terminal, that's spool out. It's all pretty simple stuff, and this contactor block seems to be working just fine. Right, let's head over to the other bench and have a quick look at the wiring diagram. Okay, so just a quick look at a close-up at the terminals on the contactor block. We've got another one here. I have a few spare ones. Again, I don't know if this one's any... Oh, they are tested okay, so fingers crossed it will be okay. We've got... flick it round. Hang on, Andy. Flick it round. There we go. That's right around. So we've got blue terminal, which is that one there. Oh, hang on, we're off camera. Jeez! There we go. Blue terminal, which is that one there. We've got the yellow terminal, which is this one here. We've got black and we've got red. And you'll see that on the diagram. We've got black, yellow, sorry, blue, yellow, black and red. And on the side we've got the small terminals. We've got the green, the brown and the black. Remember, the brown is battery negative. A little bit confusing with it being brown, but it's battery negative. Okay, so when you're spooling in, we've got the three small terminals, battery negative in the middle. When you want to spool in, you provide a positive to this terminal, which is the green. And when you want to spool out, you provide battery positive to the black small terminal. That one there, look. There you go. Okay, now, this is the interesting stuff. Bear with me. Spooling in. What actually happens in the relay? Well, it's actually quite simple. So for spooling, just to recap, we've got battery negative going to, on the trigger circuit, going to the center. It's always the case, that never changes. And then we've got battery positive being supplied, usually via your little switchy thing, your control thing, be it on the dash or your lance. We've got battery positive being supplied to the green terminal. That's that one there, look. Okay, onto that terminal there. And what happens is the solenoids then trigger in a certain way inside so that it connects the buzz bar, I call it, from battery negative, the main heavy cable on the black terminal here, the screw thread, which is that one just there. It connects it diagonally to the yellow terminal, which is that one just there. So we've got essentially inside the solenoid, we've got current flow going from here to this terminal here. And at the same time, we've got the heavy red cable, which is connected to this terminal here. This stud is being connected via the buzz bar, a different buzz bar obviously, to this terminal here, which is the blue one on the solenoid. And essentially the current flows down the wires to the motor, and the battery negative symbol, the blue terminal on the motor, is actually receiving battery positive from this terminal here. And it's called a crossover relay. And from here, we've got battery negative is going onto the yellow wire down to the motor, which is actually marked positive on the motor itself. Don't get too confused. Very simple. Red goes to blue, black goes to yellow for the spool in status. Now, when you want to spool out, it gets even simpler. So for spool out, we've got again battery negative on the trigger circuit on the center pin, the small pin just there, look. And we've then got battery positive being supplied by a little trigger switch to this terminal here, battery positive, which is the black terminal on the relay. And it goes click. And inside, it then connects the heavy black terminal here to the blue terminal, and then down to the winch motor. And we've got the heavy positive cable from the batteries being connected to the yellow cable, and then down to the winch motor. So you can see the difference here. Look, we're going basically black to blue, red to yellow for spool out, and for spool in, it goes black to yellow, red to blue. It basically swaps them across. And all it's doing is changing the polarity so the motor turns in the opposite direction. It's actually very simple, but you don't really find this kind of information readily available on the internet, hence the video. Okay, Andy, that's great. You've just shown us exactly what's written in the fitting instructions for the WARN winch that you get with the winch when you buy one. Well, that's not exactly true, because it doesn't tell you in there the internal workings and what's actually happening at the contactor block when you're spooling in or spooling out. And that information is really helpful when you're trying to diagnose why your winch doesn't work. And there is a video on that on the channel already, so if you have got a winch that doesn't work at the moment, then it's a good idea to go and watch that video, and we cover a bit of diagnostics on simple checks on how to test your winch and try and work out whether it's a problem with the contactor block or realistically a problem with the motor. It's going to be one or the other. Normally it could be a corroded terminal where you've got high resistance, but normally the winch would sort of move a little bit even if that was the case. But you know, that is a helpful video, definitely worth watching if you've got the time. Now we know we've got a working rig. We know that the solenoid works correctly, the contactor block on that rig. And now we've got 2 more winch motors to wire up one at a time to see if they actually work. I've been given these and I was told that they didn't work, but they might have been misdiagnosed. It might have been a fault with the contactor block and not the actual winch motor itself. If that's the case, hopefully one of these we can get working. Here we go. Okay, these are the 2 winches in question. This is exactly how they came into me. I have done absolutely nothing with them. As you can see, they've been in the workshop for probably about 3 or 4 months. This is all the dust from doing bits and pieces. Same make, same model, exactly the same winch. If I get my little brush, we can see we've even got the little coloured terminals on the motor at the end. We've got yellow and of course blue. Yes, sorry I didn't brush them down before the video, but makes it more authentic. Okay, so what I'll do is I'm going to install that motor, that winch, in place of the brand new one, and we'll test it. If it doesn't work, we'll pull it apart. Woohoo! Right, we'll call this winch B. Okay, I'll label it winch B, and we'll see if it works. Place your bets now. Right, I'm going to label the actual motor winch B off with the letter B because it may well be that it's just the motor we swap out. So we'll put a letter B on there. There we go. Okay, now I've pulled the cable out, so hopefully it's going to... Don't forget the clamp, Andy. Very important because there's a bit of a kickback on these winches sometimes. Okay, right, grabbing the positive. Can you see everything? You can see the contactor block. Okay, so I'm going to hold the cable. Let's see what happens. Oh dear, that's not ideal, is it? Okay, we've killed it. Okay, so the motor clearly isn't very happy. I mean, possibly it could be because maybe the gearbox seized up or something like that. But the motor just didn't seem very lively at all. It just very quickly gave up. I suspect inside there we're probably going to see some damage, corrosion on the brushes. We'll give it one more go because I'm really keen to see it move. Okay, definitely nothing there. Right, time for the other winch. This didn't quite go to plan. That's what you get when you make videos, Andy. So we've got here some pretty extensive corrosion on that pin, and I've noticed it's loose as well. So obviously that's going to be a massive point of high resistance. So maybe that's the reason why this one failed, and maybe the brushes are still okay. We could be in luck. I don't know. So what we can do, we can maybe just get rid of that. We'll use the old metal fatigue technique to get rid of the cable. You can see it wobbling around, look. There we go. Look at the state of that. Now, telltale sign, visual inspection, look, it's all burnt. It's been getting really hot because of that corrosion. It's causing it to arc and create heat. And of course, being the high resistance, the motor's not getting the current flow that it needs to do the job. On the blue one, the negative side, we've got exactly the same problem. So we'll get rid of that, just so we can actually work on there. I don't hold out any hope whatsoever of this motor actually working in its current state. But yeah, both sides burnt, overheated, and of course high levels of corrosion. I mean, look at this, I can even turn it. The whole thing's loose. So it's got so hot that that little coloured insulator has melted and allowed the whole thing to come loose. So I don't think it's going to work, but hey, what the hell. Let me get these nuts taken off, see if I can tighten the whole thing up, get the cables on, and then we'll give it a go. Well, I can't get the nuts off. The whole thing's turning. The insulator colours, these little washer things here, have melted so much I can't really get a spanner on. So just to try and in the interests of time and fun, make sure we're on negative. We are. We will just see if we can just piggyback that on with another nut. Now this might result in some sparks because the whole thing might be it might short to ground. It could be a direct short, in which case great example of why you should have a battery isolation switch. Jeez, come on, give me my spanner back. There we go. Okay, and the other one. Luckily, there's just enough threads to get these both on. But man, it could be interesting to see what happens, couldn't it? It could be a problem. Just going to give that a little bit of a tweak. There we go. Okay, we'll get you on the big tripod and see what happens. Now, just bear in mind, what I have noticed is the cable is sticking out on the other side. So, looks to me like it's bunched up at some point and started to go in reverse, so to speak. It's all bundled up on the drum. It's not correct. Can you still see? Oh, I'll back you off a little bit. There you go. I'm just going to put the clamp on, just to be on the safe side. Don't want it flying around anyway. There we go. Can you still see? You can. Right, so we know the contactor block works fine, and this looks extremely dubious. So I'm going to try to spool in first, and I'll just do it momentary first of all. Okay, you can hear the contactor block clicking. There was a small amount of movement, which I'm very surprised about. Okay, spool out. Just going to hold it on now, see if we start to see a bit of smoke. Is it getting warm? No, it's not, which is a good sign actually. Okay, right, let's cease that. And it's time, I think, to pull it apart. Oh, we need to label it up as well, don't we? Hang on, bear with me. So this will be motor C, just for reference. There we go. Okay, getting excited. I want to see what's inside this motor and the damage. Hopefully it's just those two terminals, and the motor itself and the brushes and the brush carrier, the brush springs, all that kind of stuff is still in good order. Looking at the end of the winch, and they're not light things these. At the end of the winch we've got two cap head bolts. I'm hoping we can undo those two. They're a 4mm, and then we can just basically slide the motor off the casing of the winch. I'm hoping not to completely disassemble a winch at this stage. I want to see if it's going to be possible, first of all, with the parts that we've got. I have one like this, no parts required. With the parts that we've got, to actually make one good winch out of these two. Otherwise, I have to order some bits online, won't I? Anyway, let's crack on and see how bad this is on the inside. And just for reference, this is motor C. Here we go. Woohoo! I like this kind of stuff. Now I must admit, and we've had a few comments over the years, and Simon Rule, Simon knows exactly who he is. Simon, you're one of the ones that mentioned that Ali takes a lot more stuff apart than he ever actually puts back together again. And that's actually just the way I am. Even as a small child, I would take things apart, much to my mother and father's distress. And oh, it does smell burnt actually, and smell-o-vision, and they would never go back together. That would actually include the home hi-fi unit. Yes, I destroyed the hi-fi, took it all apart, took all the knobs off and pulled the innards out, and they were very upset. Oh, it stinks. Let me just get Magic Hammer. Okay, I do like this kind of stuff. Yes, I know you're going to be very upset now because there was earthquakes. Okay, little flat screwdriver. Now, the only downside here is obviously we've got wires still connected inside, but I'm hoping that the whole lot comes out with the brush pack. I don't want to damage the seal, but it's going to be used on a trailer. It's not like it's going to be going off-roading again, so I'm not too worried about that. Right, let me get a bigger screwdriver. Okay, I'm just going to move it around a little bit so you can see what's going on better. There we go. So I'm just going to try and prise the end cap off. Ooh, look at that. Oh yes. Corrosion big time. Smell that. That's rough. That's really rough. Okay, can we get the armature out? Or is it keyed in? Sometimes they're actually keyed onto the shaft. I can't even get the end of the motor off. Maybe we're going to have to strip the winch a bit more. Okay, we can do that. Why is that not that size? Oh, come on. Oh, hang on. It's a Torx. Okay, here we go. Let's see if we can just crack those off. It's got to come apart anyway, hasn't it, at some point? So, okay, that's that one. And that one. Nice. Okay. We're conscious of that wire up, not that flying off around the workshop. Okay, that should now allow us at least to get the motor off the end. We can. And you can see here we've got the drive shaft that runs down the middle to the gearbox, and the gearbox drives the actual drum. So you've got a couple of things to line up in there when you put it back together. But the good news is it's off. Cool, it's got a spring in there. Be careful of that. Right, we'll stick that to one side. We're not interested in that side of the winch at the moment. All we're bothered about is this bit. It looks to me like it's just pushed onto there, so we should really be able to extract the armature. Oh, it's pretty rough in there, look at that. That's not ideal. Get the seal out of the way. Oh, it smells really burnt. I think this one is going to be junk, unfortunately. But we need to get it out, don't we? Maybe a punch. Stick it in the vise and we'll try a punch on the end of the shaft, the armature shaft, in there, and see if we can tap it out. Yeah, I'm expecting this whole casing to come off. That's the plan. I mean, those bolts that retain it do actually bolt the casing, the field windings, or magnets in this case, the field magnets to there. So that might just come off. Let's stick it in the vise and see how we get on. Hide hammer, magic hammer. Oh yes, we have movement. Ugh. Nasty. Really nasty. Okay. Look at the state of that. It's got a lot of debris in there. Don't know where all that's come from. It's not ideal, to be perfectly honest. But it was free. Free is always good. So all the windings, oh yes. Look at that. That one's bulged up. We've got some kind of damage. You can see all the lacquer on the wiring has all burnt off. This thing's been red hot. It really has. The commutator doesn't look too bad at all, actually, which is promising for those brushes. Maybe there's a bit of life left in those brushes, but yeah, it's all burnt. Look, all the varnish. So chances are we've got burnt windings in there. It's probably gone open circuit. It's probably shorting to ground. We could check that. Okay, I've just rigged up a little test light on there, 12 volt, 21 watts, indicator bulb, we call that in England. And just to prove the test light works, we've got the battery, just direct feed to the test light. Boom, there you go, test light is on. So, if we put a little jumper cable on there, then what we can do is we can put one end onto the shaft itself on there, and we can go onto the commutator and we can see if there's any short to ground due to that. Because this thing has got ridiculously hot, and you know, insulators break down when it's ridiculously hot. So you're looking for the bulb just flickering a little bit or coming on permanently, who knows. Okay, so that actually looks pretty good. And that should be connected to there. It is. So if any of these windings were actually shorting down onto the casing, then we would get the light would illuminate. And at this point in time, I'm very surprised but they're not, because it's been extremely hot and it's very badly burnt, and it wouldn't be very long before it did actually fail. It's in a very poor condition at the moment. You can smell the burning. Sometimes when you pull these things apart, you actually see one of these wires, one of these armature winding wires, which are a big heavy cable, because there's a lot of current flowing through here, actually melted, which is pretty impressive stuff. As you can see, there isn't anything at the moment. So there's no short to ground. Now, what we can check is if there's actually any breaks in the windings. So we should get, if we go onto the commutator, I'm not too sure how it's wound up. We've got 4 brushes, so probably at 90 degrees. So, yeah, we've got continuity on quite a few. In actual fact, all of them. So are they shorted together? I think they are, because they have to be separate windings, that's for sure. That's interesting, isn't it? Okay, and do the same on this side. It would be really good to pull the new motor apart and see how the tests compare on that one, because it really doesn't look too good at all. Anyway, it is junk. There's no way of resurrecting that. It's too far gone. It's not really repairable. It's not worth getting it rewound. You just buy a new one. What I would like to do though is just tap it out of the casing. So I'm going to get my punch, and then we can have a really good close-up and you can see all the burning on the armature. Just to clarify, maybe I didn't make myself really clear on the second part. On the first test, the bulb does not want to illuminate because we're checking that the insulation around these wires, it's only a lacquer type insulation, and if it fails, then you can see the wire coming through here, and it can short and make contact with the actual steel body of the armature. And if that's the case, the bulb will light. But if we hold it on the armature itself, we know that this piece is connected to the center shaft because we get the light. So if it lights up now while I'm going around the commutator, then we know that there's a short or a connection between the windings and the actual body of the armature itself. So we'll just run that round there, look. And as we can see, that there were no connections. So the insulation between the windings and the armature casing and the spindle is still okay. The second test, we wanted the bulb to light up, and we were checking to see if the actual windings were still continuous. They hadn't burnt completely through and gone open circuit. And to do that, we just put one probe onto a commutator segment and round the probe all the way around. Now what I was expecting is if we're only to have continuity between 2 or 3 of the windings, maybe just 1 of the windings, but in actual fact we've got continuity between all the windings, which is a little bit odd. I wasn't expecting that, but it could be, what do they call it? Field wound, I think it's called. I'm not a motor expert, so you know, if you want to learn about that kind of stuff, go and find somebody that knows a lot more than I do about it. But the fact we've got no point which the bulb doesn't light, because I think it's highly unlikely that all of them are fused together. In this particular case, if we get a point where a segment where the bulb doesn't light up, then we have a point of open circuit, or that particular winding has failed. And they all seem to be, it's only flickering because I'm going between the segments, they all seem to be okay, which is extremely surprising. So there you go. That was the test I was doing. Sorry if I wasn't totally clear on it. Okay, this should pop out of there now. Watch out for the earthquakes. Ooh, look at that. It's almost like I know what I'm doing. Okay, now you get your close-up. Right, we've got Torchy on the job. First of all, let's look at this casing. And as you can see, telltale signs. lots and lots of corrosion going on. Corrosion is the enemy for electrical devices and components, and you can see here, look, it's all very nasty. And this is one of the problems with the WARN winches. And to be perfectly honest, many of the winches on the market today, they are not fully sealed. Obviously on this side here we've got the drum and we've got some grease, but when the winch is submerged in water, of course the water can leach through. There's no real seal in here, and the water can leach through into the motor, and the motor's sort of, there's no breather pipe on the motor. It's reasonably sealed, so once the water gets in, it can't get back out. And you can see it's rusted it's caused the steel to rust. It's caused the aluminum casting to fur up as well. That's the corrosion of aluminium on there. So it's not good. There is a seal in there, which is fantastic, but there's no seal here where the shaft comes through, and there are gaps, and the water can get through, and that's why it's all corroded up. So that's the end piece. That could be cleaned and reused. There's nothing wrong with that. This is the brush pack. Now this is what really interested me. We know that the bolts are loose. I believe that they're loose because these insulators, the coloured insulators, have actually just melted basically and become thinner, and that's why it's all lost its tension. We've got where the insulator comes through on this side, we've got the wires that then feed the brushes, these two feeding these brushes and these two here. So the blue wire would feed these two brushes, and the yellow wire feeds these two brushes. Pretty simple stuff. Again, lots of corrosion inside there, and I don't know, have the brushes worn out? Have they just seized in position, which is a common problem? None of them are moving. They probably have just seized, so they could potentially be freed off, and maybe with these insulators replaced, and we have got a few spare ones on the other winch, maybe, just maybe, these brushes will be okay. I've just spotted some little posi screws down there, so I'll get a screwdriver and we'll see if we can extract the brushes. Oh, there's 4 screws, look, 1, 2, 3, 4, wow. But to do that, we're going to need to undo these bolts, and that's a bit of a problem. So I'll leave that for now, because we're doing the inspection, and maybe I can get those out. Okay, this is the armature, and you can see now just how blackened. This should all be nice shiny copper, and the reason why it's black is that varnish insulator, which coats each of these wires, has got really hot and started to burn, and it's gone black. There'd have been an awful lot of smoke given off by this process, why it's happened. Hey, maybe the winch had stalled out and the guy just kept his finger on the button. Maybe it was down to the fact we had the corrosion on these and it was getting less current flow and it was struggling. For whatever reason, winch motors do, if you overuse them, they will overheat and they'll get damaged. And it's a common problem, to be honest. People do tend to keep the finger on the button. Spool in, even as the winch slows right down. Maybe the battery was getting a bit low. All those things can have a factor on a motor, overheating. That's the colour it should have been, pretty much. You can see it there, look, with the actual varnish on it. This is completely junk. I have no problems at all in digging around and seeing what's going on, but we've got, you see there, a big chunk of varnish just hiding under there. I can't see any actual burnt, melted copper wires at the moment. But it's in a fair state. There's a lot of stuff in here that shouldn't be in here, basically. It's pretty rough. So that's that winch. We might be able to save the brushes. We might not. I might be able to buy new brushes online. I might not. But at this point in time, that's the only component that we may be able to salvage from winch motor C. Okay, well, there's not a lot of hope for winch motor C, but it all hangs in the balance now. What can winch motor B offer us? Let's get it stripped, take a look. Now, the good news of this one is these bolts are nice and tight. There's been no burning or overheating around the brush area whatsoever. Very different to the other one we just pulled apart. Now we know how to get in here now, so it's a pretty simple process. We've learnt. It's always fun. Most winches nowadays, and especially here in New Zealand, WARN, whoever the importers are, I have no idea if there is an official importer. There should be really. They don't supply parts for the motors anymore. You might be able to buy a complete motor through WARN, a genuine WARN motor. You may not. Probably haven't got it on the shelf. They'd have to order it, and it would take a few weeks, if not months, to get here. So what tends to happen is when a winch fails like this, it just gets thrown away, and the customer just buys a new one, which is quite sad, to be honest. Very wasteful. But what's their loss is our advantage. Okay, let's see if we can get this off. Remember, there's a seal in there as well, Andy. Okay. There we go. Okay, not as bad by any means. So we get a little screwdriver. Let's just see if these... Oh, that one's a bit bent. See that? Look, it's all bent. Oh, it's all to cock. What's going on there? And again, they're all seized. You can see all the corrosion around there. We'll take a closer look later on, but luckily the insulators are all intact. That's a bonus because we need those. We haven't got any good ones of those, and the bearing isn't rusty either. That's a really good sign. Okay, so what's next? Well, we can actually get the outer casing off at the moment. We don't need to put it in the vise for that. So we'll give it a little tap tap. Well, that one came off easy. Very easy to get loose. There we are. Oh, even better, the whole motor came straight out. Superb. I like that. And if you look across here, the seal is still pretty intact, so that is looking good. Stick him over there. Okay, now what we can do is we can withdraw the armature from the field magnets. And again, it doesn't look too bad in there, does it? Turn it round. Look, that's how it should look like. So, I'm getting very excited, actually. Very, very excited. I might need to take a moment. Okay, first of all, let's get the field magnets out of the way. We have got down here a small amount of corrosion. That's nothing. That can easily be cleaned up. Very happy with that. Is the seal on there? No, seal's already gone. That's good. So, looking inside, are you going to help us, Torchy? You are. Look at that. Looking inside, realistically, it's in pretty damn good nick. None of the field magnets are broken free. They're all in place. None of them are cracked by the looks of it. That's in pretty good nick. It can be cleaned up and reused without any problems whatsoever. Brilliant. Now, the armature. This is how it should look. You can see the copper's all nice and shiny. I'm not going to scratch the insulation off. That would be really bad. But if you have a look at it, it actually looks pretty damn good. Really good, in fact. So what we could do is just do the same check that we did on the other one with the test light bulb to see if we're getting contact on all segments, you know, all the way around, getting continuity in the bulb light, just for interest's sake. I'll get it set up in the vise and we'll do that. So a quick check of our bulb. Yes, it lights. We can put one on the spindle, make sure obviously it's connected. We know it's connected to there. So now if the bulb lights on any of the commutators, then we know that there's a short to the spindle, to the casing of the armature. So stick him on there, just running round, nothing around there. Now I've mounted it in the other casing for the winch just for ease of turning it. Yeah, well, that feels pretty good. No bulb illuminations as of yet. Okay, that's good. Now the next test was to see if we had continuity to the other end of each winding. However, we don't know how it's wired up, and on the previous armature from motors C, we were getting continuity on all of the all of the other commutator segments. And we are on this one as well, which I suppose is a good sign. There we go. I think that's a pass. I'm very happy with that. I don't see there's any problems at all with that, to be fair. Okay, right, we'll get the motor back out again. The armature, there we go. Stick it on the bench, keep it safe, and we can get rid of our little test rig. Things are looking very, very promising. The armature, I believe, is fully serviceable. It just wants the commutator cleaning up that I can do. I can do that in the lathe. Just get it all cleaned up, get my fiberglass pencil in there and clean out the little grooves between the commutators, and that should be good to reuse, which is excellent. Same with the field magnets, all looking good, which is brilliant. Things are actually on the up. I was starting to lose a bit of faith when I saw the condition of the first motor we pulled apart. Now, the downside here, the only real problem here is these brushes have all seized. They should spring in and out, so they're going to need pulling apart, cleaning up, freeing off. And this one here, weirdly enough, see if you can see that on camera. If we look at that one first, you see it's perpendicular, or should I say the brush is parallel to the commutator. If we come round this side here, that one is all to cock. It's off at an angle. It's sort of bent, and I don't know why. So I've got to investigate that, try and straighten it up while I'm freeing everything off, and hopefully we'll be good to go. I think we're on to a winner. Ooh, things are looking really good actually. So all we need to do is clean up these brushes, get them freed off, straighten up that bent brush holder, and then stick the whole motor back together on the winch and give it a test. Right, I'm going to grab a coffee. It's already lunchtime, maybe a sandwich or two, or three, who knows. And when I come back, after Toolgirl Holly's had a little chat with you, we'll crack on and get this resurrected. See you shortly. Over to you, Holly.
Now then, crew, Toolgirl Holly here. Don't miss the next live stream, 8:30 AM Sunday.
Thanks, Holly. Appreciate that. Now, lunch is done. It's time now to tackle the brush pack. Let's see how we get on. Well, this really is a one-shot deal. If we can't resurrect these, then we're not going to be able to get this winch fixed during this video. So, you know, no pressure there, Andy. But things are looking pretty good at the moment. So, the reason why this motor didn't actually work, didn't rotate, and the winch didn't work, is because these brushes, because they're seized in the holders, there was an air gap. They weren't making contact with the commutator, therefore it was an open circuit, and of course no current flowing, no magnetism created, and motor doesn't turn. Pretty simple stuff. So if we can get them freed off and get that one straightened up again, God knows why it's like that. It's most bizarre. And it's not from us taking it apart, I don't think, because we were pretty careful and it came apart pretty easily. So I don't think we actually caused that problem. If we can get this fixed up, then I think we're good to go. Obviously I've got the commutator on the armature to clean up as well. It's a bit burnt and crappy, so we'll get that nice and shiny again. But this is the Achilles heel. This is what I call, this is the primary fail. And they've seized up because of the corrosion. And of course the corrosion causes the steel to swell and it grabs the brush and it doesn't move anymore. I'm hoping that the springs are still good inside. And you can see the insulators inside there, they're all nice and clean, they're not melted or anything like that. So that's very important. We need those. Wasn't really sure how this video was going to pan out when I started. It might have been a really easy fix, just swapping a few parts and away you go. As it turns out, it wasn't quite that easy. So it's going to be a bit of a longer video than I hoped. But hey, hopefully it's going to be valuable to some people fixing their winches, because winches are expensive, you know. You can't just afford to keep throwing them away all the time. Right. Now we know which side the colours are because it's etched into the casing on the back, so we're all good there. See if we can get these screws undone. That's that one. Okay, that's that one out. Sorry if I keep knocking the camera. I'm trying to give you a nice close-up. Jeez! Let's use the old bionic power there. Okay, we'll grab him with some pliers in a minute. Next one, you ready? Oh, yes. Good job. I was actually going to fix this off camera, but I thought, you know what, this actually could be quite helpful to people. You know, fixing up the brush pack. I mean, in a perfect world, you just buy a new brush pack, wouldn't you, really? But maybe you're fixing this out on the trail. Maybe you live in the middle of nowhere. Maybe getting parts isn't that easy a job. Okay, so we should be able to. Have they just... Oh, they have. What the hell? This is going to be interesting. The wires that feed each of the brushes, it looks like they've just welded them or soldered them onto the end of the bolt itself. Normally they'd be on like a little C connector that will be trapped between the end of the bolt and there, so you can just pull it out, pull the brushes out and fix them up and then stick it back in again. Obviously we can't get the bolts out because this is in the way, so maybe we've got to lift all of that up first and push them in, but there's not a lot of cable on the brushes. This might be a dilemma. Now, where's my long nose pliers gone? We'll use these ones until we find them. How's that? Right, that's screw number 2. Nearly. Screw number 3. And screw number 4. Okay, so the brushes are no longer held in place. I am going to get my yellow pen. Hang on. I just want to mark the brush pack, so when it goes back in, we're sure we get it the right way around. Put a little line on there, a little line on there. Can't go wrong. Now, how is this going to work? Now, be careful not to break that plate that's holding the whole thing. Ah, cool. That's freed off. That's freed off. Jeez, make it very awkward. I've never come across one where it's all been one piece with the bolts. I wonder if they do that deliberately to make things difficult for people. Can we get the brushes out of the holders in situ? That might be the answer. Maybe. So I don't want to break the brush or any of the brushes because we haven't got any spares, but there's plenty of brush depth left in the holder. You can see in there, look. So maybe we'll just give it a little spray down. See if we can get this one freed off. Oh, it is wobbly. That one's wobbly. Okay, so we need to get him out of there. If we can get the brushes out, then we can lift the holders and the board out of the way and then push the bolts in. I can feel a spring in there. Maybe we can just grab all of that. Look at that. Fantastic. Okay, that's one. Let's get some more lube on the rest of them then. And hope we can do the same. It wasn't overstuck. It was just a bit stuck. He says. patience is what's required. And of course, when I edit this video up, I might be... Yeah, you can still see the spring in there. Look, the spring still looks pretty good. So that's the spring. So we can take those out. So it's not corroded at all. It's in pretty good nick. However, we need to do that 3 more times without breaking anything, which is not going to be easy. Be very careful with these brushes, because if we break one of them, that's it. Pretty much game over. See, maybe if you focus on that one, we could then maybe tip the whole thing across and push that bolt out. So we may not need to free them all off at the moment. It's weird. What was that? Oh, there we go. A bit of crap. See if we can push him back a bit. Man, that one's pretty sick, pretty stuck. Where's my pointy one? There he is. See if we can scratch some of the crap out of the back there. I need another pick. Bear with me. Corrosion. It's awesome, isn't it? I think I saw a bit of movement on that one. Nope, still absolutely solid. Poor thing. See if we can push him from the back. Ooh, it's not ideal. I don't know where to stop with this one. But yeah, it's definitely, you can see there it's been soldered onto the end of the bolt. So when you buy the new brushes, if you can get new brushes, you get 2 brushes and a new bolt. Very cautious about going down the side of that. I can see it. See, we've got a gap here and a gap here, and the brush seems to be stuck down this side here. So maybe, I don't want to crack the brush though. I would say maybe leaving them overnight in some Coca-Cola or something might help to just free everything off. Very difficult job. And nobody but me would even bother doing this. I quite like the idea of a free winch, one that works. That's got some movement on that one. I just know I'm going to break it. It really is still stuck. See if we can just flex it. We've definitely got a gap down this side here now. Can I get a gap up there? Feels like there is. Hey! Wow, a bit of patience, that's all it took. There you go. I think it's still sort of usable. Let me get a small brush. Now obviously it doesn't matter which brush goes into which holder. I don't think they're handed, but it'll naturally sort itself out when it goes back together. I think we've got that out there pretty well actually. And I still think there's some meat left on these brushes. Okay. So now with those two out, we are halfway through the danger zone. Okay, let's see now if we can lift this up and get it over there and remove that. Yes. Look at that. Okay. So now, on camera, Andy's good. Now we could just extract that one out. Not that we really need to, but we'll take it out anyway. And there's the insulator. Okay, perfect. So yes, they are definitely sort of spot welded onto the end of the bolt. You can see that there, look. But I think with a little bit of light cleanup, we can resurrect those. Okay, that just wants a bit of a clean out, so we'll stick that to one side for now. I think the bearings, yeah, the bearing's fine. We'll leave the bearing alone. Haven't got a spare one anyway. Okay, so all we've got left now are these two, and for some reason that one is slightly bent, so I'm going to have to tease that one back somehow without breaking it on the board. But let's get the brushes out first. In fact, we'll have that spring out there before we lose it. There's that spring, so we've got two good springs. We do have the other one anyway that we can always maybe salvage a piece from. I don't know. See if we can get that one out next. And of course we've got a bit more access now that it's not on the board, but it's not on in the casting. But it did take some doing there, and I don't want to rush it. So apologies. It's not easy. And see, here in New Zealand we can't just go and buy a new brush pack. Chances are it'd probably come as if you were able to get it, it'd probably come with the casting already fitted. Let's give it a little tap. No, still no movement. Yeah, see if we can push it back. That's always a good way of doing it, because then that way you're not... Oh, geez, that was my finger. No, that's still solid. But again, it looks like there is a gap down this side, and it seems to have seized on this side. Just trying to flex the metal a little bit to come away from the brush. Hey, here we go. Whew. 3 out of 4 ain't bad. There we go. Okay, so without further ado, I'm just going to put, hey, you've got an O-ring on there, don't forget. We're going to put a little line on there as well. That came out of that side. That was that pair. Stick them over there. We've got one more to go, and this is the one that's been damaged somehow. I don't know how it's been damaged, but it has. This forge spray is pretty good, isn't it? It's just full service spray. It just seems to, you know, giving us a bit more lubrication, which is important. So again, I think with exactly the same problem, we're sort of free on this side, but we're not free down this side. So we'll just try and ease that bracket, the holder, away from the brush a little bit. Still very solid at the moment. I don't want to try and bend it back up with the brush in situ. You can see how bent it is. It might have even been like that from new. Who knows? Who knows what's been going on? But that board actually feels cracked. Yes, it is. It's cracked under there, the mount board. So something's happened to cause that to break. So be very careful with that. Very careful indeed, he says. Right, we must continue because you'll be getting bored. Yeah, there's definitely a gap down there. And we can tweak all these up again with some pliers before we refit the brushes. This is stab your fingers territory, isn't it? I felt movement. It gave a little bit. Okay, let's see if we can get in the back and push him out like we did the last one. Oh yes. Look at that. Can we get in there? There we are, we'll just give it another. Right, I think we might be in business. Nope. Bit dubious about using the pointy ones because it could cause the brush to break. Let's have some more lubricant. It should just come out really. See if I can work it a bit. You can see it moving now. So what's holding it in? Is it corrosion? Oh, we can get in the side now. There we go. This one's definitely the most reluctant. There we go. Okay, those two are out. We have that spring and that spring to remove. Perfect. 4 brush springs. 4 brush holders to try and clean up. Not ideal, are they, to be honest? But we'll give it a go. And then I can just very lightly clean the sides of the brushes just to give it a fraction more clearance. And then we can stick it all back together. Okay, let me see how I get on with cleaning this bit up and straightening up that holder. You can see the difference. That one's pretty much straight, and that one's definitely over a few more degrees. That one's straight. Oh, sandwich. That one's straight. There we go. So, not concerned about the corrosion on the outside. That's really relevant. It's about it, trapping the brush. The brush needs to move freely inside the holder. The good news is all the springs look to be in good order. They don't look to be particularly rusty, so I think they've still got their tension, which is important. They need that. Right, put it to one side for a second. I'm just going to put some brake cleaner in here. I want to try and keep it out of the bearing if I can, because obviously we want to keep the grease in the bearing. There we go. Got a little paintbrush. We'll just whizzle that round there. Just trying to keep the Keep the fluid out of the bearing if we can, as much as possible. I can always flick the seal off the bearing anyway and put some more grease in it. That's not the end of the world. Oh, somebody's out on his quad bike. Nice. In fact, I think I'll do that. I'll flick that little seal out and we'll post a bit more grease in there later on to give us a chance to have a quick visual on the bearing as well. I think it's pretty good, to be fair. It feels really weird having a Saturday where I've got no contractor jobs to do. You know, I've done all we can on the bonnet at the moment. I've just got to put a parts list together, so I can do that on an evening. All the plates are made for the footwells. We've been making loads of those this last year. Last 18 months actually, we've been really busy with that. And it's just nice to have a little bit of time to do a few things that I wanted to do. And I thought you'd maybe like to join me on this winch resurrection. There we go. Right, let's give that a little bit of a blast out. Try not to get on the camera. Not looking too bad, is it? A little bit down there needs scratching out. Sounds like an old Honda quad bike, does that? Seems to be a few in the village. Right, so I'm going to take it off the camera, hang on. There you go. Much better. Okay, where's my pick gone? There he is. Right, seal removal time. It's never ideal, but we'll give it a go. There we go. Oh, look at that. Beautiful. Okay. So what we need to do there is I'll give it a blow down with the airline, and then we'll just stick a bit of extra grease in there. That bearing looks absolutely mint. Okay, mind your eyes. Oh, we'll take the bit out there. There we go. Not too bad. Right, we need a little bit of grease, so we can use a little screwdriver for that. There he is. Get some grease on there. There we go. Plenty. That's more than enough actually. Need half of that. Right, so we'll stick him in there. It's always good to add a little bit extra. That will work its way around. Not too concerned about that. Maybe a bit more. Maybe we're a bit stingy. Okay. Right, seal back in. Oh. Easy as that. Just pops straight in. Nice. Okay. Apart from a bit of light corrosion on the casing, I think we're probably about good to go with that one. I could get the Dremel out and a little wire brush, but I mean, you know, how far do you want to go? You want to see it working, right? Okay, happy with that. A little bit out the bottom there, look. Yeah, that'll be right. Okay, that's ready when we get the brushes sorted out. Right, brush pack. Flat screwdriver. Now, first of all, I've had a go at trying to straighten them out, and man, they all look to be, where are we? There we are, look. They all look to be a little bit over to one side. That might be deliberate. I can't comprehend why it would be deliberate, but it might just be a worn thing. You know? So we'll leave them alone because it's very delicate on this backing plate, and I think there is already a crack somewhere, so don't want to destroy that. This is our only hope, don't forget. So I'm just going to clean out the rust bottoms first of all. Making sure I'm supporting them as I'm doing it, because again, I don't want to put any too much stress on the crappy little mount, which of course is an insulated mount. It has to be. Okay. In actual fact, the base is this material. It's not metal at the bottom of this holder. So I will continue to try and clean the sides and get rid of any kind of rust deposits along there. I mean, the fact we've got them out in one piece first is a bloody miracle, in all honesty. Miracles do happen. We can clean the tops out like that. And there is quite a bit of corrosion in there. I can see. Where's Torchy? Is he going to help? You can't really see too much, can you? But poor Tang Tools mat. It's done well over all these years. We don't have to worry about the contact between the brush and the metal because it's all insulated anyway. All we're really bothered about is to make sure that they move freely. Otherwise, they're going to lose contact and continuity with the armature. A nice new brush pack would be very useful at this point in time, but it's also quite nice to get something working again. And remember, the only reason why this machine, this winch failed was because of water ingress, which is a common problem on winches. Probably the most common reason why they fail at all, to be honest. That and people just continuing to winch spool in when they're clearly not going to get out and the battery's nearly flat and the winch motor's red hot. As hot as the centre of the sun, then they wonder why it fails. Okay, let me go and find some contact cleaner. Oh, that's bugging me. And we can spray this and then leave it while we clean up the brushes. What I'm doing now is completely irrelevant. I just feel better for it. And if the backing board breaks while I'm doing this, I'll kick myself, won't I? There we go. Right, contact cleaner. Okay, this is the Forch R570 contact cleaner. It's really good stuff, actually. Don't use it very often, but when I do, it's brilliant. And like I say, we're not worrying about it making contact. I just want it to hopefully remove some of the corrosion. Right, we'll leave that to soak for a bit. And we'll move on to the brushes, which we could probably also use contact cleaner on, actually, to get it, make a start. Oh, it stinks. Oh, it really stinks. Okay, I think we'll start off with a bit of Scotch-Brite. This stuff is absolutely brilliant at cleaning things up without being too harsh. Oh, look at that. That is amazing. I wonder if we can do it the other way around, where I just move the brush across it. No, better like that. Okay, where's my screwdriver? Let's just see what we've got on here. Looks pretty good. new one. So you haven't got Scotch-Brite, you could probably use some really fine sandpaper without any problems at all. And of course you'll need a little flat screwdriver just to scrape off the crap. It's obviously, you know, worn brush material and rust and stuff's got in here. And that then takes up the clearance between the brush itself and the holder, hence why it jams. Plus the holder rusts as well. And all of a sudden you have a problem. Okay. Mrs. Mechanic was talking about YouTube videos today and how she can make her channel better. So I said to her, hey, you need to come up, because she does crafting work, you know, makes cards and that kind of stuff. She loves doing that kind of thing, but she's not really launched her channel yet on that. And I said, well, what you need to do is you need a point of difference. I says, what's the problem with most of the craft channels out there? She goes, oh man, they waffle. They tell us what their dog's done for the day and where they went shopping and looking at a new sofa, you know. And it's like, well, I don't want to hear any of that. I want to know how to make a card or how to do, what does she call it, embossing and stuff. Totally foreign to me. But I says, well, you need like a no bullshit crafting channel. Straight to the point. This is how you do something. Job done. Next, you know, moving on. End of the video, kind of thing. None of this bullshit talky stuff. And he said, that's a really good idea. I says, the added benefit of that is it's really quick to edit up, right? You're going to have some nice short videos. You're going to get lots of views, and people will get exactly what they want immediately, and then be able to do what they can carry on with their lives. They're not listening to you waffling on for hours. She said, that's exactly what I need to do. So that could be a success, couldn't it? Right, well, that looks a lot better, doesn't it? Very happy with that. So 3 more of those to do. Cool, that really gets your hands after a bit, doesn't it? Okay, so the plan of attack is we have to put the brushes in the same way that they came out. So we can do one side first. And looking at that one there, we've almost taken it all off. Just put the mark back on again. So that was the one with the yellow paint. Put some on there. Put some on there as well so we don't mess it up. And we're sticking over there. This was the side with the yellow paint. So, oh no. There. Whoa, yellow paint. Just. So we'll stick some more on there. It's amazing when we start cleaning things up how you clean off your marks sometimes. Okay, so that went on there, I believe, like that, with the insulator down the bottom. Only makes sense down the bottom. Could be wrong. We'll find out. Now, we need a spring. So we'll stick a little springy in there. Need another spring. Stick a little springy in there. Can you see? You can see. This is great. And now, if all goes to plan, we should be able to just push that brush in. Oh, look at that. And it should just pretty much stay in. Obviously, once it's in position with the commutator, it will stay in. So we'll have to just pop it in there for now and then just tidy it up later on. But we can now fit that into the holder. I wonder, actually, it might be easy to put the brushes in. I think we'll put the holder in first, actually. Looking at this, that will work. So we'll put the other brushes in just so we don't lose those. There's that one in there. That one in there. Okay, now for the screws. We'll stick those in because it's easier at the moment to do that. That's one. Two. through it. I'll have to see if I can try and get hold of some more brushes actually, just for stock. Since I've now got two winches that are the same. Right, 4. There we go. That's all of them. Brilliant. Okay, so we'll work on this side first. And I know we labelled it up. Is it important we labelled it up? Probably not. But we did, just to be on the safe side. So that goes through there. Oh, can we get it in now? Maybe we can't. No, we can't. Oh. So we've got to fit the brushes, the bolts through the holes, then put the plate in, and then put the brushes in the holders. Okay. You see, we're learning together on this. What's wrong with another couple more minutes on the video length, eh? Yes, I know we could edit it out, but that would be no fun at all. Okay, so what we'll do is we'll just pull that back out. It's got the springs already in it. We're going to stick in through there like that. Pull the brushes back out of the way. We're going to stick in through there like that. And to be fair, there's nothing to stop us actually putting on the, just tentatively, minus, that's the blue. We can put the blue insulator on, which goes on there, and then we can put a nut down it, so a bit more lubrication required. We're on camera, we are on camera, this is amazing. And we'll stick him down there out of the way, just to hold it all together, if nothing else. That's one. Right, so this side is positive, so it's the yellow, and it goes that way around. And we'll stick him on there, a bit of lube. There we go. And we'll just do it finger tight for now, because there's no need for any more than that. Okay, all the brushes are up out of the way. We can now get our brush plate, and that way around. Stick him in there. Oh yes, now we're cooking on gas. We can stick the screws in. That's one. Two. Three. Last one. Woohoo! So close. Right. Okay, now we can pop the brushes in. Now they're probably not going to stay in for very long, but at least they're going to be in. Do they flow freely? Yes, that one does. Didn't before. We fixed it. What, this one? Is this one going to throw freely? We've had a few. Ooh, we've had a few issues, haven't we, with bent bits and stuff, so that one's a bit tight. Let's try these ones. Might need to do some minor adjustments. Yes, that one's nice and smooth, springs all the way out, doesn't stick. How about that one? Is that going to go in? He is. Right, so that one is good. He says. It's all fingers and thumbs now, sorry people. Yes, there you go, look. I wonder if there's any kind of lubrication you can put on these. Probably not, actually. That one's good. That one's good. So the one we've got a problem with is this one. And why is it a problem? What is going on? Has the brush holder been squashed? Did I squash the brush holder? Or is it just getting caught on the spring going in? Don't think so. See, they've got a little recess at the back for the spring to clip onto, or to locate to. There we go. Right, it is in and it is sticking. As you can see, it's not moving freely. That would be just as bad as it was before. So, where's my pick gone? There he is. We need to get him back out again. There he is, look. Okay, so he's out and we can see quite clearly where it's rubbing on the top. Something is not happy. Bottom looks pretty smooth. So I wonder if there's still a bit of rust stuck on the underside of that top piece. So we'll just fish out the Mr. Springy. Make sure he's safe. And can I get in there with a pick? Maybe I missed something. Right, let me fix this, and then we'll come back and we'll continue with the video. Okay, a few minutes later, you didn't want to watch that. That would have been, you know, you'd have gone off and watched TV instead. Okay, let's try it again now. I haven't pre-tried it. If it doesn't work, I have another plan. We know it goes in. Yeah, it's still a little bit tight, isn't it? Look. Okay, better. But what we can do, just to cheat a little bit, and it won't matter, I've got a little file here. I'm just going to file the brush a little bit smaller. Should we do the other side as well? Should do, really, shouldn't we? I think this is less risky than trying to bend the already fragile brush holder. Okay, let's try that. We haven't taken much off. It might be all we need to take off. Right, spring is still in place. Fingers and thumbs, Mr. Young. Fingers and thumbs. You come around this side. There we go. Oh, he's still sticking, but he's better. In fact, he's a lot better. Brush material is very soft, so just working it a little bit will probably mean it'll be just fine. Well, that feels perfect to me now. That's probably just scratched off the bit that was in the way. So we'll stick the other ones in. Again, that's that one. And see, there's no way of holding them in. Sometimes you get like little pins and stuff that you can put through the brushes, but on this particular one there isn't anything. I'm just doing a final check now, so there we go. He's in, he's back out. There we are. Right, so they've all been checked again and they're all fine. So we'll leave that for now. Sorry, that was my hand for the last 5 minutes, wasn't it? All done. We'll leave that for now, and all that's left to do now is stick this in the lathe somehow. We'll work out how to do that and give that commutator a bit of a clean up. Let's go the other way. safer. And it was only lightly, tarnished, so we don't need to go mad. And I'm just using the same Scotch-Brite again. I don't want to resurface it with the actual tool on the lathe because I don't think it needs it. Shiny! Don't drop it. Right, back to the bench. Jum! Honestly, that took, I don't know, a minute in the lathe, if that. Super quick and easy. Right, I'll give it a little bit of a clean down. And what we have here, and I could just have used this to be fair, but I don't like to wear it out, is a fiberglass pencil. Yes, it actually has no lead and it's not made of wood, it's made of plastic, but it's called a fiberglass pencil. And if we turn the end, you'll see there we get fiberglass bits sticking out. What we can do there is we can use this a lot better than using sandpaper. You should never ever use sandpaper or even wet and dry on a commutator, because what happens is the little tiny particles of friction material, or the abrasive material, gets embedded into the copper. And then once you build your motor back, oh, looks nice and shiny, it's all good. You put your motor back together, that abrasive then wears down the brushes really quickly. It's a bad idea. It does work, but it doesn't last for very long. And that's why often a new set of brushes then won't last anything like the original set. So if you use a fiberglass pencil, it's still got the meat, the beans to clean out all the bits. But I don't think you get the same problem by using the Scotch-Brite pads. But this is how you can do it as well. I'm just making sure that all these little grooves here are nice and clear and there's no debris stuck down them. We'll give it another blast with a brake cleaner as well, just to clean it off. But just want to make sure it's nice and good. You can see how shiny it is now. Look, those brushes are going to be really happy making contact with these commutator segments. I'm so happy. They'll be having a party tonight. You wait. I really hope this winch works. I'm sure it will, but you never quite know till you know, right? Okay, that will do. We'll tuck the old pencil away. It's not often I use that, but it's very good. You can get them off Amazon and bits and pieces. Super useful. There you go. That's definitely clean. Okay. It is that time, ladies and gentlemen. We can now reassemble the winch. Sounds a bit like James May, doesn't it? So, yes, it's time to put it back together. It really, really is. I think the only thing I've got left to do is just to clean out a little bit of rust from the field magnets. So I can do that off camera. I'm pretty sure you know how to clean out that kind of stuff. I will do that. And then the next time you see me, we'll be putting it back together. And then we can test it. And then you'll get to find out whether Andy actually knows what he's doing or not. Hopefully, this is not an easy part of the task. Got to try and hold all of these back, all the brushes back, as we pop in the commutator. And of course, it's almost impossible. I don't know how successful this is going to be, but it can work for you, I'm sure. We'll wait and see. It's a bit fiddly, but it's sort of a guaranteed outcome, whereas at the moment I have actually tried this a couple of times previously, and it's proved to be almost impossible for me to hold all 4 brushes back and at the same time put the armature in position. So we will just do one at a time, and we will cable tie them all back, and then I'm hoping that once it's in, there we go, we can then just cut the cable ties and everybody will be happy. Now obviously it won't work like that, we've got to put that little piece round the side. A bit more around the side than that if we can. There we go. Cool. That's one. You sort of get the idea of what I'm trying to do. We're just using a cable tie to hold it in place, and then we can just flick the cable tie out once the armature is in position. That's the plan, Stan. It might not work. I might run out of patience by that point, but we'll see, because it has to be done, because you guys want to see this winch working. So I don't have a lot of choice, and I want to fix it as well, to be fair. Sometimes manufacturers, they just don't make things easy for you to do, and they would much rather sell you a completely new motor, already assembled, good to go, bolt it on, sir, and you know, spend your money and you're good to go. Well, I'm not that kind of guy. I like to fix stuff, you know. So fix it we will, and we have, in actual fact. This is just, the fix is already done. This is just the assembly. Okay, we need to bring him round a bit more, because he can't go there. He's in the way. Come on, mister. I have got some, in fact I've got some smaller ones. Hang on. Nice. There we go. It's all about having the right tools for the job, Andy. Okay, I'll snip him off. 2 more to go. See how easy this is? I just hope there's enough clearance from the end of the holder to where the brushes currently are. I'm pretty sure there will be, but you just never know. And of course, one of you guys out there will go, Andy, there's a much easier way of doing that. I'm sure there is. What would be nice is if they had put a slight hole in the brush just here, and you could have put a pin in there to hold it back. Yes, Andy could drill some holes like that, but this is another way of doing it. Right, let's get that all the way around. There we go. Okay, brush is going in. There we go, brush is in, moving nicely. We'll hold the brush over there. There we go, let's tuck him down there, look. It's not going to fly off. And we can snip that one. Careful not to cut the wire on the brush itself, obviously. Right, that one wants to go on that side, so we'll see if we can thread him through there. Of course, being the last one, it's going to be a pain in the ass. There we go. I've tried putting them in from the top, but they just seem to, oh, there goes the air compressor. They seem to be a little bit tight to get in. Now, obviously, these are not a permanent feature. This is just to help us get the commutator in place. It's a neat trick. Or not quite so neat, to be fair. Whoa! Stay down. Right. Okay, brush going in. There he is, nice and loose. We can feel that. Flick the zip tie over the top. Okay, now we need to move that down a little bit. Not a lot. There we are. Okay, so all 4 brushes are now held back. I'll do you a close-up so you can see, but they are, which is nice. Yes, I know it's 4 cable ties that we're never going to be able to use again, but hopefully that will work. Okay. It's going to be tight. It's going to be really tight, but we might just be able to do it actually. In fact, if I push those down with my screwdriver, then that should work, because then we can get the commutator on the top half of the brush. That's just enough. Oh, it's going to be close. It's going to be really close. Okay. Whew, have a look at this. And you thought you'd seen all the boring bits. Not quite. Okay. Commutator needs to go in there. I'm trying to give you the best possible shot that I can. Well, that was pretty easy. Okay, so at the moment, if you can see, maybe I can tilt it slightly with torchy, the commutator is just basically halfway down, and it's now against all of the brushes, which is a good thing. Now all that's left to do is to remove the cable ties carefully, and then we can push it all the way down onto the brushes. So this is going to be immense amounts of fun, and I really need some little tiny snippers. Let's see what I can find. Brand new little tiny snippers. How cool is that? So again, we can't afford to have it jump as soon as the cable tie is off. We can't afford to have it jump out, but oh, look at that. That's pretty cool. There's one. So we can tilt it over slightly, rotate it round. Oh my word, can't believe how well this is going. 2. So then we can tilt it down to that one. Okay, next. Very important not to catch the insulation around the brush wire. There he is. Okay, there's a bit of it there, look. We needed that out. Right, we've got 3 out of 4. Maybe I can get it from this side. We are so close. There we go. Oh, sorry, camera. Guess what? I'm not retaking the whole lot. Right, it's in. Phew! That was fun. But it bloody worked. So very carefully, we don't want it to fall out. We've now got, if you look in there, look, you can see all the brushes making contact with the commutator. Which they are. So that's really good, actually. Really, really good. Because it wasn't before. Okay, sorry, off camera. So that's really, really good. You can see in there, look how the brush makes contact with the commutator across there. And it's all super clean and tidy. Very happy with that. Right, without dropping it out, so let's get this installed into the casting. Okay, so very carefully don't fall out. So you've seen how the brushes interact with the commutator now. We've still got the rubber seal on there. All that's left to do now is to lower down the the casing. Now I've marked on the side of the casing where the blue terminal needs to be, so we can slide that down now carefully, because it is magnetic and it will pull up the armature for it. Jeez! Careful. Okay, it's on, and all we need to do now is rotate it to about there, and then we're now in a position to fit this back onto the winch. Woohoo! Right, said Fred, I've mounted it in the vise so you can see what's going on a bit easier. Just want to clean out some of that last bit of dirt that's in there. Not that it really makes any huge difference, to be honest, but shows that I care. That's what it does. There we go. Now, where's my brush? I forget a little bit of grease. The rubber seal is still in there, intact, so we'll just get a bit of grease and just brush that around. Yes, a smaller brush would have been better, but it's all I've got. There we go. Okie dokie. Now if you want to grease that bearing as well, it doesn't feel too bad. It could actually benefit from some grease. Hang on. Whilst we're in, why not? Okay, it won't take a second to do. Better to do it now than not do it. I think we've got just enough left in here. Boom. That is definitely enough. Happy with that. Put the cover back on, little seal. Just pops straight in. It's they're really good actually. Here we go. Wow, been quite involved as this. Yeah, that's alright, that's cool. Quite involved, this little fix. Okay, so WARN sticker to the top, and we also need to make sure that there keys in at the other side. Do you remember on there? Here's one I prepared earlier. We've got this little slot it has to line up with, so that should be fun because that could be in any position. Where is it? Maybe we can get it vertically positioned. Flat screwdriver. Is that going to fit? Yeah, I think so. Okay, that's straight up and down. So the WARN sticker is up and down, is at the top, 12 o'clock. So if we just do that, we should about be there. Oh, so good. Right, I didn't clean up the bolts. You could do that. It's late now. We'll stick that in there, and these are also vertical. Now, where is... Oh, it's all the way over there. Is that going to stay there? Keep an eye on that. Don't let it fall. Phew. Knowing me, I will probably... Yep, that's not quite the right place. Let's just extract that. Whoa! I'm going to pull that out. Pliers. Sorry, camera. There we go. Okay, just need to rotate that a little bit, I think. There we go. I can feel it going in now. And now I've lost the Allen kit. There he is. Right. Okay, that's now threading in, and it is correct. We've got blue to the front, Luckily, we've got a nice new one to look at, you see. Makes life a lot easier. We'll stick that one in there. So both seals are in position. Just going to tweak that up. Tweak that up. Tweak that up. Woohoo! Now it's time to see if this repaired winch is actually going to work. Will it work? Who knows? Bloody should do, really, shouldn't it? Right, yellow to yellow. Stick on the nut. Blue to blue. It's so easy when you've got a little rig set up like this. It's just mint. Stick it on there. I did do a bit of preliminary work before this video, which is most unlike me. Okay, relay's already wired up. All I need to do now is apply I think we'll need to do spool out first, which is to the black. So I need to put the connector on here. Can you see, first of all, before we do this? Oh yeah, pretty much. Okay, so we're going to go for a spool out first. Let's see what happens. Oh yes! Nice, spool in. Fantastic! Couldn't resist. It's always useful having a winch in the workshop, but these two winches, the brand new one that we did nothing with, it was just used as a demo really, and the one that we've fixed here, the B winch, the B motor, these two winches are both going to get fitted to my two IFA Williams trailers. One's the large triaxle and the other one's the LT105G, which is the small twin axle trailer that I have as well. So it'll make my life so much easier. As I'm getting older, I try to problem solve and make life a bit easier for myself, and I often go out and have to recover stranded ROVs. Engine won't start, or a belt's broken or something, and they've lost drive, or the brakes are all binding on. So much easier to chuck the winch on and just winch it, drag it onto the flatbed and take it home and fix it at home, rather than, you know, struggling with things like ratchet straps, trying to crank them up the ramps onto the trailer. Just an absolute ball ache. So very, very happy that I've now made a usable, and it sounds great. It was instant fire up. The motor sounds really happy. All the mechanics on it are obviously going to be fine, I'm sure of that. The gearboxes give very, very few problems. There is a video actually on the planetary gearbox of these WARN winches. That's also on the channel, so you can check that out. But also, if you enjoyed this video and found it helpful, and it turned out to be a completely different video to what I set out to do. This video was purely intended for showing you how the relay's wired up and maybe swapping a brush pack, you know, hey presto, fixed winch. But as with most things in life, the work wasn't as simple as that. It required a bit more finesse, a bit more time, and my Saturday's pretty much gone. But I now have a winch which here in New Zealand would probably cost well over $1,000 for free. Just a couple of hours work, 3 hours work in the workshop. And of course it takes me a lot longer because I'm filming. But if you haven't already subscribed to the channel, why not click on the subscribe button, ring the bell, that way YouTube will send you a notification as and when I upload any new videos. You'll also find me on Facebook, Instagram and Twitter. Feel free to communicate through any of those portals. You can also email me, andymechanic@live.co.uk. That's live.co.uk.
So Andy, how can viewers support the channel?
Well, Holly, thanks for that. I'll let the viewers know how they can support the channel. Very good point. You can do that through PayPal. Just send your payment through to andymechanic@live.co.uk. Same email address. and you can just fire it through, whether it's $1 or $5 or whatever you want to send. It all helps to go towards making more videos. It all gets ploughed back into the workshop. I don't really do any retail work anymore. I have a full-time job, and the workshop doesn't really bring in an income as such. Do a bit of fabrication work now and again, but it's just sporadic. So whatever you send over, it certainly helps to keep things rolling along. You can also become a patron via Patreon, and you can set up a regular payment each month of, I think $5 is about the cheapest you can do. And often, although not recently, I do upload short videos and images and stuff to the Patreon page as well, so you get access to all of that. So there you go. That's about it, really. It's been quite a fun day. Hopefully you've enjoyed how the internals of the contactor block actually work, so that will help you if you're trying to test your winch and it doesn't work. Then at least you can work out where the power should be going, whether you're spooling in or spooling out. One dirty trick, realistically, if your winch isn't working and your relay block's going clickety click 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 whenever you press the button, just grab some jumper cables, battery positive, battery negative, and jump straight onto the motor of the winch. Now obviously make sure that the free spool is engaged, so you're not going to pull the wire rope in further and jam the whole thing up. But if the motor works under that premise, and you can just reverse the jumper cables to get it to spool in or spool out, if it does work, then you know that the problem is most likely the contactor block. If it doesn't work, then the problem is most likely the motor on the winch itself. It's a very quick and easy check to do, and I often do that, to be perfectly honest. Using a multimeter and checking the voltage is pretty futile, to be honest, because it may not be able to carry the current. Whereas if you use some decent jumper leads, you know that the circuit's good, you know the battery's good. If the motor's not working, you know it's the motor. That's it. It's simple. Okay, crew, I've got to crack on. Workshop's tidy up. Might still be doing another video later on today, unless I get called in for tea. So I'll see you next time. Thanks for watching. Cheers. Over and out.